All right, my name's Carol, and I'm here to talk about databases today. A little background on me, for those of you who don't know me. Got my degree in computer science more than 25 years ago and went straight into consulting. And my role has been, sorry, it is on. Sorry, I'm trying to figure out if I could clip it better. Is that better? Okay, sorry about that. I went straight into consulting. My role with Bikini, we started Bikini in 2002, and my role with the company has been more project management and database. I'm very focused on the database side of things. My official title is CEO, but I really like going by database goddess. If you have any questions, feel free to interrupt me, and we'll take them as we go along. I'm going to talk today, what I'm talking about today is a couple things. Logical database design, physical database design, and then some tips on databases and using databases with Xojo. For us, almost all the projects we do are database related. All the Xojo applications we write have databases with them. And I know on the forums there's a lot of questions about databases. So using databases is an essential skill, but most programmers don't have that background. So what I'm trying to talk to today is a fairly high level, should apply regardless of what database you're using, and give you some ideas on how to structure your programs better. I'm a big fan of Stephen Covey. He has the 7 habits, and the first habit is begin with the end in mind. So what you want to do is you want to think about where you're going with this project at the very front, and what I'm talking about here applies to any size project. So what is a good database design? An important feature is that you don't want the same data in multiple places. You don't want the same place. You don't have to go multiple places to go look and update something. If you have a good database design, it helps ensure the integrity of your data, and it supports the business in such a way that you keep your code and your database separate. So if one thing changes, as it invariably does, you're not having to do a whole lot of rework. So how do you create a good database design? I'm going to talk about each of these steps. First of all, focus on your purpose, find the data you need, organize it, and then normalize it to make it better. And we'll talk a whole lot more about normalizing. So defining your purpose, you need to figure out what you already know. There's a lot of times you'll come into a situation, there's some sort of existing system in place. That system might be spreadsheets, it might be an older system that they use part of the functionality but not all of it. You need to start digging to say what's already out there. For our projects, we always go through and document the purpose. It may be a very simple, we always do contracts with our clients. It may be a very simple statement of work in the contract. It might be emails between the key user back and forth, so we kind of say, here's what we think you need, here's our assumptions, here's where we think we want to go. And whatever that document, however you document up front, you need to use that throughout the process and keep referring back to it. Then you need to find the data that you're going to need on the project. What happens is a lot of times, a lot of times they'll have a system and they'll use part of it and not part of it, or they're using the system not in the way it was originally designed to be because they couldn't make it work for what they needed. You kind of need to dig into those pieces and say, what's working with their current process and what isn't. The next thing is to collect data on major subject areas, and we'll talk a little bit more about that. And then you want to think about how the user's ultimately going to need to see the information. And a lot of our projects will have an end user who's giving us the requirements. I need this, this, and this. For instance, we work with an insurance broker. So the person who's paying the commissions will be giving us all the requirements. But ultimately, it's the CEO of that corporation who's the end user, because he's the one who's going to want the reports out at the end. And the way he wants the data sliced, you okay? The way he wants the data sliced is completely different than the operational way that we're putting the data into the system. So I'm from Chicago, so my sample database design here is we're going to talk about pizza, because that is the best pizza. So a lot of times we go in and look at the existing system, and it'll be something like this. It'll be an order system, and the database will be designed just like this. You'll have the customer name, the order information, all this stuff jammed into one long table. And we're going to go through a process to talk about how to design it, and the answer is not like this. So, like I said, the first piece you want to kind of do is organize your data into big subject areas. So subject might be customer, or order, or your food, your inventory, that sort of thing. And then for each of those areas, like customer, you start breaking down the details. So on the customer information, we will have, what's the customer name? First name, last name, do we care about titles, that sort of thing. Then we'll have contact info, including addresses and phones. And then we'll have some kind of possibly a customer status information. I'm a big proponent of using pictures, especially with your end client, whoever end user is, to be able to relay what you're doing and how the pieces are all fitting together. So I use what's called the data model to do that. So what is a data model? It's graphic representation of the tables and columns. It includes big chunks, entities, which are basically your tables, attributes, which wind up being your columns, and the relationships between them, which is your foreign keys. A data model is friendly enough that you can use it with your end user, but you can also have it be rigorous enough that it can actually generate your database. It'll generate data definition language that'll create the database. So here's a sample data model. This is a real simple customer address and phone. I did this one using a tool called Navicat. There's a bunch of tools, and we'll talk a little bit about tools too. The little crow's feet are called cardinalities, and they help you define the relationships between things. And the way you read it is from the customer, you've got the crow's feet at the end, that thread is one-to-many. So a customer could have one-to-many phone numbers, or a customer could have one-to-many addresses, and each address going back up has one and only one customer that it's tied to. We can talk more about that. I'll talk a little bit more about that as we get farther down. There's a way to do that, yeah. My third principle is when in doubt, split it out. So I got dinged from Dana on this slide. It's like, that's too many words on a page. And the whole point is, I'm not going to read it. I don't want you to read it. Normalization is something that there's books and books written about this. There's a whole lot of theory behind it on how to do it right, how many levels of normalization, all that kind of thing. I'm going to try to keep it simple, just talk about 3 levels of normalizing. The whole point is you want to minimize redundancy, increase the integrity, and make it easier to use the data for updating data, that sort of thing. So why do you need normalization? If you have the data properly normalized, the database structure itself will stay constant, even though your business processes will change over time. It isolates the code from the data, which provides stability. And then basically what you want to do is have all of the columns in a table dependent on the key of that table. And again, less issues when you update data. So, very highly simplified steps on normalization. As I said, first of all, you kind of list out, you go from your subject area down to entities, which are tables. What are the main tables you want? And what are those columns? What's the list of columns you have? For each table, you define the logical key. You assign, and then you're going to go and look at the key and say, well, do you have the right fields on that table given that key? And we'll talk a little more about that. And then you make sure that there's no repeating groups and everything is dependent on the key. One of the things that happens, and the examples I'm using here are pretty simple, but what you do logically may be somewhat different than what you do physically. And we'll talk about some reasons for that too. So the first normal form is no repeating groups. I can't tell you how, we get a lot of projects we inherit from other people, and I can't tell you how many times we've had things where it's like phone 1, phone 2, phone 3 listed on the customer table. But that's not what you want. You want to just have a single group. If it's something that's repeating, it belongs somewhere else. The second normal form means that you don't have key combos. Basically, if the table has employee, project, and department as the key, then the only thing that should be dependent on that would be dependent on all three of those. And to give a little example of that, if you have employee name, department ID, and department name in a table, well then if the department name changes, you'd have to change it on every employee record. So that's saying it's not directly dependent on the key. So we'll go back and talk a little bit more about some examples here of common patterns you'll see in common paradigms you'll see in doing designs and databases. So one of the most common ones I see is a header detail. You'll see this with order and order lines, department employees. It's a one-to-many kind of relationship. When you're going through and doing the design, things you want to think about are things like, is the order status kept at the header level or at the detail level? So are you going to track each line being complete or the whole thing being complete, or both? Another thing for this pizza example, where are you going to keep the prices? Well, you probably have prices down at the lower level, but what if they have a coupon? How do you apply that to the prices? This is the model I came up with for just tracking the order-to-order lines. And you can see I have some of the additional details on the address here too. So things to think about, again, you have, for each customer, can have one-to-many orders. Each of the orders has one-to-many order lines. The customer is the foreign key into the order, so you'll see the customer ID is on the order. The order is the foreign key into the order line, so you have the order number on the order line. Any questions on that? Okay, another common example is a hierarchy, and this is used in org charts, that sort of thing. In this case, the employee has an employee number, which is like the number on their badge. And what we want to do is we want to be sure that we're keeping the employee ID separate from that number. We'll talk more about using meaningful keys in a few slides. So in this case, the supervisor is also an employee. So the table basically points to itself. So that's your hierarchy. And as you see it in the example data, the person at the top doesn't have a supervisor ID because they don't have a supervisor. And each of the people below that, they point to the record above them as their supervisor. So in summary on good database design, you want to begin with the end in mind. Pictures are worth 1,000 words. And when in doubt, split the data out. So now I'm going to go a little bit, that was a lot of fairly logical discussion. Now I'm going to get a little bit more into the physical side, what happens when you actually put it in the database. I'll have some design tips, a few naming standards, and I'll talk a little bit about tools. First of all, keys and indices. You always want to use non-meaningful primary keys. The example I gave earlier about the employee ID. I can't tell you how many times we've come in and somebody's used, last name as an ID or social security number, where these things are not supposed to change, but then you hit things like somebody gets married or a person's an undocumented employee, an undocumented worker, you don't have a social security number, something's going to happen. All of the databases we work with have tools built into them to help you with this. They will have the ability to do a auto increment. You set it up as not null, and it becomes your unique key. We also recommend not storing calculated data. Sometimes from a performance standpoint that becomes necessary. And one of the other approaches we use is if you've got, like, for instance, we have a database that stores documents. So that's a big blob of data. What we do is we put that into a separate table, document ID and the blob, so that that data is separate. We can move it to a separate database if there's a performance or a size issue. Just keep it clean. One of the things we make a lot of use of is views. We consider views to be very helpful in terms of being able to make it easier for the programmer to deal with the data. Let the database person design the views, and then the programmer just use them. For example, we do a lot of accounting systems. And so one of the things we'll do is we'll have a view that'll be able to say, what's the current balance on account? So whatever needs to be summed up, debits, credits, whatever, all that logic is in the view. And again, every programmer that's on the team uses that view. You don't have to replicate that logic anywhere. I personally, and this is maybe just me, but I personally don't like using triggers. The reason I find them bad is because basically they're updating the data and you can't trace what's going on in the code. I've seen a lot of people use triggers. I think there's better ways to get around the kind of logic that you need in triggers, so I generally don't advise using them. Naming standards. I'm a big proponent. It should be a singular name on the table. It should be the customer table, not the customers table. Adding the S adds no value. These are just some other standards I've worked with over time. Don't have the table name be customer data. It's not adding value. Our approach is generally to have a prefix, the subject area, and then what's the detail of the data as part of the table name. So example, TR customer type. And I'll talk about what that prefix is in a minute. T order line item, that sort of thing. On the column names, we'll have the attribute and then what's the classification of that column. Excuse me. So it'll be customer ID, order date, order amount, that sort of thing. We use these prefixes across all our database projects. T for table, V for view, that sort of thing. On the tables, we have 3 different types of tables. If the table is just a reference table, a lookup table, like a ID and a description, things like status tables, that sort of thing, we use TR as a prefix. If it's a regular table, it's T. And then going back to the earlier question, if it's a table that's resolving a many-to-many, it's a cross-reference table, and those things are named TX. Other considerations, when you're naming columns and naming tables, don't use special characters or spaces. Some databases will let you do it, and then what you'll find up later is it's going to be a problem when you're using a query tool or something else. I just find it better not to do that. Be real careful not to use keywords. We've had databases before where someone named the table group, and it's like, no, that's the worst name for it. You're gonna have to manage that separately. Just avoid it. Come up with your own standards on how you want to manage the case. Do you want to do everything uppercase, lowercase, camel case? Do you want to have underscores? For example, we always have our unique identifiers for a table be underscore ID. It's really easy to find what those things are. Mm-hmm. Yep. The point being, depending on the database, they are case sensitive, and sometimes they're even case sensitive depending on which platform you're on. That I think it's MySQL that you can have a parameter that says whether or not it's case sensitive. You should come up with a list of standard abbreviations to use in your table names. For example, we decide up in advance, are we going to call the customer tables cust, or are we going to spell out the word customer? Employee, the same sort of thing. One of the decisions you can make is if you on the attributes, if you're going to put the classification as a prefix or a suffix. So is it going to be order ID or ID underscore order, something like that? You know, your date field is going to be DT, DATE, how are you going to name them? And then we'll also, even depending on the size of the application, have prefixes based on the grouping. For instance, we did a large accounting system, so all the payroll stuff was prefixed with PR, accounts receivable, AR, that sort of thing. I want to talk just briefly about database design tools. I realize most of the people in here are not going to go and do a great big investment on them, but just want to explain a little bit about them. First of all, there's a category of what I call true database design tools. These are tools that are designed in such a way that if you draw those diagrams like I have, you push a button, it can create the whole database for you, including your indices and everything. As I said, one of the ones I use is Navicat. There's Toad and Irwin on Windows. Some of these things are pretty expensive. I think, I believe it was Irwin was like $5,000 a seat. So I don't use a lot of that. That's how come I like Navicat. It's specifically set up. You can buy the database design module, but you can also buy separate add-ons for whichever database you're using. If you don't want to go to the extent of having a true database design tool, there's lots of ways you can draw pictures. Visio, I've seen lots of people do them in Keynote or PowerPoint too. Bob's talking some more about coding mistakes in Xojo, and there's some pieces of this that's some overlap with his, so I'm not going to go a lot of details into database encoding in Xojo. There's an approach called ActiveRecord, and it's implemented in a lot of different languages. I think it originally came in with Ruby on Rails, but it's out there in PHP and Java. And basically, this is a whole approach where you map your table to classes in your project. Basically, I really like it because it does the autocomplete. The IDE can do the autocomplete of your table and column names. The compiler can catch your mistakes. And depending on how it's implemented, if you have a table, like a column in a database and it's not in your project yet, it can catch those things for you. ActiveRecord uses prepared statements. It has standard functionality for before and after updates and creates. This is my alternative to doing triggers. This is where we put the code. So if every time you update a row, you want to update update the columns that says who created the row and when was it last updated, it's all in the standard spot in the code. We have a product called ActiveRecord Generator, ARGen, that is designed for Xojo to be able to implement ActiveRecord. Each of the data class, the ActiveRecord data classes are in their own namespace. You're given options on how to handle the property names with prefixes and suffixes, so it helps you implement your naming standards automatically. We released version 3 last year. It's got a couple new things. Support for SQLite and iOS, a few other things, audit trails. We do a lot of audit trails. It's just nice to have it there. It also generates UI for desktop and web, which is handy. Basically, what you put in your database design, and it pumps out a Xojo project that's got a lot of the code already started for you. It puts in pragma statements to say, here's where you need to update your code. So, in summary, begin with the end in mind. A picture's worth 1,000 words. Data models are great graphics to use. And when in doubt, split it out. And ActiveRecord's an option to make a lot of that happen for you automatically. Any questions? Yes. Okay, so the question is have we developed some procedures for like updating the database? And yeah, we have an approach, and what we'll do is we will have that in the code. We'll have what version of the database are we on, and there's a constant in the program, in the code, and a value in a table in the database. And so when the app starts up, it checks that, and based on where it's at, it'll say, oh, the database is only at version 33, but I've got stuff up to version 35 in the code. I'll go ahead and update the database as I open up the app. Does that answer what you, yeah. I don't know, Bob, do you have an opinion on that? We've done both. Yeah, I think my tendency would be to put it in the database. That way I know where it is and I have control over it. I'm thinking huh? I'm sorry. The question is are there databases that are better for handling blobs than others? I'm not sure. I don't know that I would say specifically this one is good or this one's not good. I know we've done it in MySQL. We've done it in Postgres, yeah, and SQL Server. No issues. The question is, what kind of limits do you have on the data? I'm thinking some of them have a limit on the overall database size, but really, we get some really big databases. I mean, gigabytes even. Yeah. Yeah, so the comment was about databases and sizes, and you really have to work with the databases. There's a whole lot. I could do another whole talk on indexing and managing indexes and performances. There's a whole lot of other things you can do. Did I see Chuck? Okay, so Chuck's comment was he has an opposite situation where he has files that are gigabyte or bigger, so he doesn't want to store them in the database. So what he does is he actually creates the file, the physical file, and then as part of a transaction, he doesn't commit the transaction until he's sure that the picture of the file, whatever it is, made it there. Yes. Yep. The comment being that there's ways. What you can do is you can put ways of checking that you've got the right file in there. And I'm sorry, you said just you do a sum of it. Oh, a hash. Yeah, a hash sum. Just to say, is this the same thing? Do I come up with the same value? Yeah, I'm reasonably sure I've got the right file. We use a wide variety. SQLite's a really nice lightweight database if you don't need a database server. It's a single file and that's all it is. A lot of our projects are either Postgres or MySQL. Again, for us, a lot of it comes down to there's questions on licensing, that sort of thing. I think Postgres is a little more lenient than MySQL is. I also work on some commercial apps, and a lot of those things are SQL Server. Just depends on how big and what are the user needs, really. And a lot of it, too, is on what platform they're going to, too. Yes?
This might be a slightly loaded question. But once the design is done, what on a single program or team, what comes first? The database, the intro database, or the code?
So the question is it sort of a loaded question? What comes first, the database, the actual database itself, or the code? And in our world, it's always the database design. We get that nailed down, because if you get that right, then the code follows. Yeah.
There are apps pretty much like Django, which is a Python thing, where they automatically generate all your database access code from your database.
Right.
Actually, sorry, it's the other way around. They generate the database from your code. So you create objects, models in your code, and then say, and it says, okay, here's all the people I'm just going to do. It's a beautiful way to make it.
That's interesting. So it's called Jenga?
Yeah, you have to build the model. Yeah, you build the model in your code.
So Jenga is an approach where you build the model in the code first, and then it generates the database. That's the first I've heard of that. That's interesting.
It's really sweet, though. It's very fast to get.
Okay. Other questions? Okay, I'm sorry. You said you've got an approach to this, and you're on Friday? Okay. So from the model, you generate the upgrades similar to what we're doing with ARGen. Okay, yeah, and there's a lot of approaches out there for that, definitely. I would ask if you guys have feedback. I'd love to know if this is too high a level, if this is stuff you already know, if there's other database topics you'd like to see covered at future XTCs. I'd really appreciate the feedback. Bob? Mm-hmm.
Just based on the sheer number of databases that you get from developers, why is having the customer name repeated row after row and order status and everything else, why is that bad?
So the question is why is it bad, given the pizza example I showed, to have the customer name repeated row after row? And what happens is you have the same data in multiple places, so you can't say, if I just want to update the customer, like, they move to this new address, I can't update it in one place. I don't have the ability to get to that data. And that's why the whole normalizing things out makes your life easier as you go down the road. Is that a full enough answer? Exactly. So the comment is okay, if you have a customer table and you have an address table and then the customer moves, are all those old orders then pointing to that old address? And I would say what you need to do is think about what your requirements are up front. In the case of a pizza delivery place, that might be okay that all the new ones go to the new address. But if it's I'm sorry? If it's an accounting database, yes. And you want to track, yeah, historically, this is where that data went. So then you might have a separate timestamp on the row, and this is the current address, and here's the former address, and here's the time at which that address was valid. So if you need to go back and look and relate it to orders.
Customer table has the current customer valid address. That changes what we give all password or have full. Well, okay.
Well,
okay, all right. So, yeah, so Carol, you talked a little bit about it with the customers with addresses and phone numbers and emails.
mm-hmm.
You kind of glossed over why that was a one-to-many relationship.
Okay.
Yeah, so why do that?
So why do you have multiple addresses? You can have there's multiple reasons. One of which is if you need to keep this history. Another is if you have to have different address types. For instance, you might have a ship to and a bill to and that sort of thing. So you don't want to include all that repeating data on the order. You want to be able to split it out and be able to point to the exact address you need. Here's the one, and here's the reason for that address.
Well, and the other thing is that customers have addresses, suppliers have addresses, and so you can kill all your address needs.
Right, and we do this on all our projects. We completely normalize that stuff out. So you have an address table, you have an email table, and you have a phone number table. And they each have types on them, so you can have cell phone, home phone, whatever. But those could be pointed to by a customer table. It could be pointed to by a vendor table. It could be pointed to by a whatever, company table, whatever else you may have. They're all pointed to that same address table, same email table, same phone table. Yes.
Or would you have an address table that's many to many people that just assign that address table?
So the question is, if you have a company table with many employees, do you have an address on the company and an address on the employees, or do you somehow point the company to the employees? And I would say that depends on your analysis up front on what do you need. Are you going to need to track different addresses for the employees? If the only address you care about for them is the company address, then there's no need to carry it on the employee level. Does that make sense? Okay. Yes. Mm-hmm. So the comment is that a lot of the databases support processing within the databases. So how do you decide where you put, what do you use the database for, and what do you do in the code? For transparency reasons, I tend to put a lot of stuff in the code itself so that you can trace through and see what's happened. Because like I said, on the triggers, those triggers fire and suddenly your data has got different values and you have no idea why. There are, some of the databases support stored procedures. We use those a lot of times for like reporting, just because it's just one place to put all the report kind of procedural logic. Bob, did you have a comment?
Yeah, my comment was the time to start thinking about the procedure is if there's another data source, there's another source that's connected to that data, or if it's speed, especially over the network, having a database or having your application query for a lot of data, the network can be really slow. So sort of procedure can be incredibly fast because everything is processed. So speed would be my primary focus.
Okay, so Bob's comment was in terms of deciding what you want the database to do versus the code. Speed's a big factor, that if you can have the database do it, it'll be a lot faster. And then if there's other sources, like more than just your code accessing the database, you might want some stuff in stored procedures so they all have a common place where they're getting whatever that code is. So Gino's comment was one place they do use triggers for keeping track of the last updated time and date for a variety of reasons. And that is one case that I have done that in the past, and that is because you just want to have every table, in our case generally, every table has who created it, when it was created, who updated it, and when last it was updated. And the logic for updating those fields is the exact same no matter what table it is. So you can just have, that is one place where you might want to have a trigger, and so anytime the table gets updated, boom, those fields get updated. Any other questions?
In your database work, I've used primarily the Xojo tools that are available. Sometimes I use some Christian tools that are generally use the tools or tools that
I'm not sure to access to read the data to.
Yeah. I mean, how do you connect to the database?
Just
almost always.
Yeah.
We have to use the platform.
Is there something? I'm going to say we don't usually have an issue with that. We usually have a default for each of the databases we use, and that's yeah, I was going to say I don't have an issue with that. I haven't done that much. I'm sorry. The question was, I hadn't said anything about collation, dealing with like German letters, that sort of thing, and we haven't ever had an issue with it, I don't think. We generally have whatever the default is for the database we're using, and we haven't had to deal with that. And it could be that I'm just not doing a lot of things with foreign languages. Okay, so Kim's got a session on. Okay, so Ken's got a session that'll talk more about text encoding. Any other questions? One last.
Regarding data types, are there any that you would avoid, like Boolean and things like that?
Are there any data types I would avoid? No, I can't say that. I generally try to use the data types that's appropriate to what the purpose is. Some of the databases don't truly manage the data as a data type, so you kind of have to look at what database you're using.
You had things like varchar, would you have them always put them in as the 255 and that sort of thing?
Again, I try to do analysis to say what realistically do I need. The question is there's varchar and that sort of thing on there. Do you always use that? And again, I try to do enough analysis to say what do we really need for this. Let's not just dump a bunch of 255 character fields if that's not what you need. Is that it? Thank you.